Welcome to springlib.
We want to use CAS software to graph f of x is equal to 1 minus e to the 1 over x all over 1 plus e to the 1 over x. Then use that same software to find the first and second derivatives and graph those derivatives to estimate intervals where the function is increasing, decreasing, intervals of concavity, inflection points, and any extreme values that the function might have. So I went ahead and graphed f of x here already, and I chose this window here because I just kind of zoomed out a little bit, and then I saw as x went to infinity and negative infinity, it looked like it just approached y is equal to 0, and there wasn't really any other important information, I thought. All right. Then I went ahead and already graphed and found the first derivative and graphed that over here on the right. And before we actually find our intervals where the function is increasing and decreasing, notice that on our original function, at x is equal to 0, the function is undefined, since we have this kind of piecewise function going on right here. So now what we need to go ahead and do is keep that in mind when we are finding where the function is increasing and decreasing, because we know even though it looks like our first derivative should be defined at x is equal to 0, we should know that we shouldn't get a value for it. So our interval should always exclude 0 in this case. All right, so remember, we know a function is increasing when f prime of x is strictly larger than 0. And so starting from the left, it looks like from negative infinity up to 0, it's positive, and then 0 to infinity. And it will be decreasing when f prime of x is less than 0. And from this graph, it doesn't really ever look like it will be less than 0. So there are no intervals of where the function is decreasing. And even just looking at f of x, it does look like it is always increasing. So from this, we can conclude that we have no local mins or local maxes. So no local min slash max. All right, now let's go ahead and go to the second derivative here. And all I did to get this window was I just zoomed out far enough to ensure I got all my x-intercepts. And those x-intercepts occurred at negative 0.417 and 0.417. And again, even though it looks like x is equal to 0 would be 1, we need to go ahead and exclude x is equal to 0 from this. All right. Now, if we want this to be concave up, we want to find where f double prime is strictly larger than 0. So that's going to be from negative infinity up until negative 0.417 union with, then starting at 0 up into 0.417. So that will be our interval where it is concave up. Now, the function will be concave down when f double prime of x is strictly less than 0. And that will just be the rest of our interval. So negative 0.417 to 0 union 0.417 to infinity. All right, so now our two x-intercepts, excluding x is equal to 0. Well, to the left of this, it is concave up. To the right of it, it's concave down. So that tells us we'll have an inflection point here. And similarly, for our other x-intercept, it'll be increasing to the right, decreasing, or concave up to the left, and concave down to the right. So this is also a point of inflection. So we found our points of inflection. We found where the function is concave up, concave down. We determined the function should always be increasing, and we have no local maxes or mins.